Hey everyone, we'll give people a few minutes to join and then get started. Okay, so I think we can probably get started now. People might be joining over the next couple minutes, but seems like we have quite a few people, so we can get underway. So today we're talking about stateful applications. Running this webinar is going to be myself. I'm Kyle Rome. I'm a field engineer here at Rancher, so do a lot of pre-sales type engagements, running POCs, professional services, that type of thing. And with us today, we have Niraj from Kasten. Niraj, you want to introduce yourself?
Hi, everyone. Neeraj Tolia, CEO and co-founder of Kasten. I'll do a longer intro in a little bit, but very excited to be here.
So just want to let you know kind of how this will play out. This is one of Rancher's masterclass series. So this will probably be about a 45 minute presentation, and then we will do a Q&A after the fact. So feel free to enter your questions as they come up, but we will wait until the end of the presentation to answer them rather than trying to interject them throughout. So this session's being recorded. We're going to put it up on our YouTube channel afterwards. So if you missed anything or want to go back and review, you will be able to do so. Also, we have a channel about these masterclasses, so you can keep up on the schedule within our public Slack channel that you can sign up for at slack.rancher.io. And these are a couple of our upcoming masterclasses. So a cloud native applications deployment using K3s and traffic, and then managing SQL servers on Kubernetes. And so those are scheduled for September 24th and October 1st. So those will be the next couple. And you can view which of those are also upcoming on our website. So we're going to be using Rancher during this demo today. If you are interested in setting it up for yourself, Rancher is completely open source. So if you go install it, you're going to have all of the features that you see here today. There's no enterprise versions or enterprise gated features or anything. So there's a few different quick start guides that use Terraform and Vagrant on our website and our docs. So if you want to play around with it after this, feel free to go there and do so. So I'll pass it over to you now.
Thank you. All right, I think we should be good to go. Let me full screen this. So thanks everyone for making it today. I'm very happy to be co-presenting this masterclass with the fine folks at Rancher. And today we're going to be talking about day 2 with stateful applications in a cloud native environment. What it means for you when you start running databases, NoSQL systems, and other such services there. So at the very high level, we're going to cover a few things. We're going to talk about some of the different design patterns that we're seeing with data in Kubernetes and how the world has evolved from where Kubernetes started. We're going to talk a little bit about cloud native data management too. So we're focusing on what's changed from a traditional VM-centric world? What are some of the common misconceptions here? What do you need to track? And then finally, how you get it right. Again, things to watch out for, what it means in the Kubernetes context, things of that nature. And the goal will be to get through some of these things quickly, but feel free to ask questions. We will definitely get to most of them, if not all of them. And then we'll have a bunch of live demos using both RKE as well as Kasten's K10 data management platform. We're going to be doing this on Azure today. All right. But before we also jump into things, let me tell you a little bit about myself. As I briefly mentioned earlier, I'm co-founder at Kasten. We are a Series A funded startup based here in the Bay Area. And in particular, my focus has always been on infrastructure, but also building teams that can build lasting technology. When I go look at my experience, I spent a few misguided years doing research, a PhD at Carnegie Mellon, a few summers at Intel, a few years at HP Labs, and then quickly discovered I wanted to do something a lot more real. I joined the startup called Magnetics that EMC acquired, so spent a couple of years there. Was also a technical advisor to a storage company called Hedwig that recently Commvault acquired. But throughout my career, the common theme has been scalable storage systems and data management. And this is something I truly feel passionate about. And I'm very excited to share some of the things happening in the cloud native ecosystem and some of the ecosystem advances, and hopefully help people not make some of the mistakes I did when I got first started with Kubernetes in 2015. So very, very early days. All right. Now, just in terms of high level stuff, right? Sometimes there's also this misconception that Kubernetes is only built for stateless applications. A, I think that misconception is quickly being proven wrong. And B, the second part is there truly is no such thing as a stateless application when you go look at anything real out there. Hey, apart from toy examples, everything has state. It has in-memory state, it has on disk state. In the early days, some of the state was pushed outside of Kubernetes in different contexts, but very quickly we've seen large-scale deployments of data being served from within the system itself, and a lot of apps people might be using on a daily basis are likely getting served out of Kubernetes today underneath the hood. So that said, want to quickly look at just the design patterns we are seeing in terms of customer deployments and how they're deploying stateful apps. And it really is one of these situations where it depends on the use case. So the first concrete example we see is that when you go look at your Kubernetes cluster, you will see that data services, whether it be Postgres, something relational, something NoSQL, will be deployed in the same namespace as the rest of the application components. So your web server tier, some caching tier, etc. They'll be all deployed together. This is a rather common pattern we see. And something subtle there, if you notice, is we will sometimes see multiple data services in the same application. And we'll come back to this later when we touch upon polyglot persistence. We also seen this other pattern emerge as deployments are getting more mature. And when you go look at people running hundreds of Kubernetes nodes in production, we've sometimes seen databases or data services get split up in a different namespace compared to some of the stateless, so to speak, components within the system out there. So this is sometimes tends to be a homegrown database as a service offering, but sometimes this is how people are scaling out their systems, and we've started seeing some of that. And finally, how some of the initial applications started, but still a real use case, is that your application components sit containerized within Kubernetes, but they're leaning on some external data service to run, to store your persistent data. This could be examples of this include managed data services in Cloud SQL in Google, AWS RDS. On-prem, you will sometimes still see databases running in VMs. But over time, we are seeing an even broader shift of people moving these data services into Kubernetes, so following the first couple of patterns that you see on there. Now, the common thing across the board, and that what we're going to focus about, is once you have these data components tightly tied to the application out there, what does data management and data look like? Day one, it is somewhat easy to get up and running there. But for this presentation today, we're going to focus on data management and in particular on protection and mobility of this. That is, once you have real data there, what do you put in place to recover when things go bad? And generally, when things go bad, the first couple of things people think about is, hey, I have accidental or malicious data loss. I accidentally delete a namespace, which cleans up everything in there, including all your persistent volumes. I might have a ransomware attack. There was some hole that someone else exploited. There is a possibility of infrastructure or hardware failure, and doesn't matter whether you're on-prem or in a public cloud. Recently, folks in AWS lost EBS volumes because of a power outage there. So you see this across the board. And how do you come back from this and come back quickly is the issue. But there are other also use cases that we see when you talk about application misconfiguration. If you're not doing GitOps or someone manually changed something, how do you come back from that environment? You dropped a few replicas by accident. So things of that sort also happen. Compliance and auditing requirements, when you need to prove to someone this is what it exactly looked like 6 months ago in the cluster versus what my Git repository said the config should be. So those are some of the other reasons why you want to be looking at all the state in your system today. And really, independent of who you go with, the key management, the key elements I would focus on when you evaluate systems, first of all, is automation. We've helped customers recover from real outages, and support for end-to-end automation for everything is critical here. You don't want manual steps. It really messes with your RPOs and RTOs. You definitely want scheduling and policies, sometimes for non-obvious reasons. Right? You want policies so they can pick up on new applications coming into your system. We'll talk about this later during the demo. But you also want scheduling not just for backups, but also retention. And this is a cost reason, where if you say, hey, I want to retain everything going back to a year or multiple years, it ends up being very costly in terms of storage. So what are the right kind of retention policies you want to think about when faced with protection? Obviously, security, encryption, table stakes today, won't spend that much time about it, but you want roles, you want encryption, you want authentication, authorization, all of these should be first-class citizens. And finally, right, a backup is only good as being able to test that on a regular basis. So recovery testing that is non-destructive, something that can be sandbox, having DR tests is again critical. So all of these combine to form a critical part of someone's data management strategy. But in the cloud native world, it is again about operating at scale. So how do you do things in a multi-cloud world, multi-cluster, as we are a part of an ops team supporting multiple business units on your infrastructure? You might have multiple applications you're responsible for. So how do you do this at scale when you're spread out literally across the world in certain scenarios? And that is something we focus a lot on within Kasten too. So I'm going to switch tracks a little bit and talk about cloud native data management and what's different here, because data management per se isn't new. People have been doing it for a long time. And in particular, there are very successful examples in the VM-based space. And when we talk to customers, they look at these initial VM-based platforms and they talk about themselves as mismatch between solutions built for VMs versus what you need for a very dynamic environment like Kubernetes. So one of the big changes is obviously the infrastructure. Nodes scale up and down, applications scale up and down. The notion of an app is constantly shifting and changing. There's also no external visibility, and you don't want that. Maybe your MongoDB cluster is deployed in a way that's just local to your namespace and does not have external visibility. So how do third-party apps that always were able to get into something get there? The constant deployments, people are deploying multiple times a week, if not multiple times a day. App infrastructure gets repaved. We'll show a couple of concrete examples of also state and services explosion. What used to be a VM is now hundreds of different components. So these are all the challenges of trying to force a traditional solution to adapt to it. But sometimes the bigger thing is actually user and role changes that have shown up. We have to remember that platforms such as RKE are very application oriented, very developer oriented. Developers own the full stack, they own the infrastructure. So why should they also sometimes not own data protection? But how do you do it in a secure way? How do you do it in a way that ops can enable self-service? What are the cloud native APIs, right? You don't want to deal with yet another set of APIs with yet another authentication scheme out there, right? How do you directly integrate into this? How do you plug this into your CI/CD pipeline? How do you automate this in a first-class manner? Those are all the requirements that really show up in a cloud native system out there. Let me make this more concrete by just showing you an example of how one would recover, say, a Postgres database in the VM world. It generally looks very simple. You shut Postgres down. My mouse seems to have disappeared. You shut Postgres down. You restore the backups. Maybe you have logs you apply to it. You run recovery. You restart that backup. This simple playbook no longer works in a containerized world because as soon as you shut Postgres down, your pod or your compute unit, your container just disappears. So when you're doing this in a VM-centric world, it gets a little bit more interesting where you are scaling Postgres down, you are then have to create some recovery separate pod or job to recover stuff, run recovery, shut that down, scale it back up. So large number of changes there as to recovering something in a Kubernetes-centric world versus a VM-centric world. And it's also useful to look into real applications, right? So this is an example of a customer's app running within Kubernetes today. And what we see is there are multiple persistent volumes that they have replicated data services, but also state that used to be a part of on the stake, think configuration, secrets, certificates. All of these things have exploded and become a part now of Kubernetes state, whether it be stored in etcd, available through the API server, right? They are all now separate components. So when we think about how we want to also, what it means to back up an application, move an application, it's all these components and not just the stuff that sits on disk or in a managed data service out there. Yeah. So we're going to also next, just switch tracks a little bit to talk about some of the misconceptions too of applying data protection in this environment. Right? We'll frequently run into people that says, look, I have storage level infrastructure that takes care of it. So I have a backup and recovery product that goes into my NetApp system or goes into EBS, snapshots those volumes, maybe moves them somewhere else, and that'll take care of it. That works great when you're looking at just the on-disk state. But as you saw in the slide previous to this, right, there's a lot of state, large number of components that are part of Kubernetes. So you're missing out on a lot of those. Your restore playbooks are manual. We've seen this with customers. It tends to be quite complicated where you're bringing back snapshots. You try to create PVs in Kubernetes that correspond to that, PVCs, reapply the app stack on top. You hope you got the right set of snapshots when you're bringing back 15, 16 volumes that were tagged correctly. So it leads to issues there. This has led to people sometimes building out custom scripts for these apps too. And that actually works great on day one. It's tailored to the application, it gathers this. But again, what we've seen is they're more complex to maintain than expected. So when we look at applications, they deploy, as I mentioned, being deployed and updated very frequently in this environment. So the script needs to track that, new services coming in, others going out, difficult to maintain, difficult to test, often tied to infrastructure. So when you need to re-platform, if in a hybrid environment, picking a new cloud provider, how does that work? And finally, something else that we also see is that people saying, let me adopt a storage overlay that spans my hybrid and as in my on-prem, as well as my public cloud option. And this maybe can do backups for me. Maybe it'll help take care of my disaster clear of migration needs. So it's my storage system that does it all. And anyone that has scar tissue in this space knows that you don't want to store your backups in the same system that has done your protection. But also, if you've picked an overlay as an example, you sometimes get cost and management complexity of two storage stacks. And I do not think that you really need this in terms of the performance cost versus being able to pick the best of breed, whether it be EMC or NetApp on-prem, EBS or Google Persistent Disk in a public cloud. I believe data management should be abstracted from the choice of underlying storage providers. And that's really what today we focus on at Kasten today. That is, in this world, how do you do data protection and mobility for Kubernetes? We focus on backup recovery, disaster recovery, application mobility in these environments. And in particular, we focus on both multi and hybrid cloud use cases that show up very often, as well as polyglot persistence. That is, when you have multiple data services in the same app, how do you handle those in a consistent manner? And we'll go through some of that also. How we do this is we treat applications as the operational unit there. So performing full app capture, so not just the stuff that sits on disk, but also all the other components that make up your app. We can abstract away underlying infrastructure. So if you want to make this portable, that's an option. And even though Kubernetes is what people call a desired state system, sometimes there's still some coordination or sequencing of actions that are needed. So we make sure we perform those two within the context of it. And it is our fundamental belief, and this is also what differentiates us, that data management needs to begin at the application layer. We can't approach it from a storage system point of view. We can't approach it from a bottoms up. It has to be top down, because it's what balances the needs between ops and devs in this environment. When you go look at the operator role, people care about compliance management. They care about policy-based automation, making their job easy. How do they get visibility to everything happening across clusters, across clouds? And they don't care about the 600 components that make up a single app. They care about the app there in that context. Is my app protected? Is my app robust? Is my app reliable? And from the developer side, it's about giving them the controls when they want it, giving them full control over the stack, including protection, including policies, but not slowing them down. If they don't want to worry about it, they don't have to. If they want extensibility, they are able to modify any portion of the workflow. Right? They want to mask data in a certain manner. They have custom encryption. They want to quiesce in a particular way. So how do you give these folks the tools in a secure manner such that they can not impact other applications, but do everything within their system? And that is what we do today in the K10 platform. So enterprise focused, where we do full app discovery, completely transparent, no changes needed to develop for developers or to your pipeline. A lot of policy-driven automation stuff. You'll see all of this in demos in a little bit. A lot of workflows and scheduling support, compliance, monitoring. But for extensibility, we also use this open source framework called Kanister, where this can do simple things like app consistent snapshots, quiescing a database, and then snapshotting volumes, all the way to finding out at runtime what my replica is so that I can go and just snapshot that without impacting the primary, or extracting consistent data from an eventually consistent system, masking data, things of that sort. So there's a lot of power available in Kanister for operators, security offices, or developers to extend the workflow depending on their requirements. And obviously, right, and this is a lot of similarity to how Rancher approaches the market too. We care about giving customers choice about where they might be running, what kind of distributions, what kind of storage they might be running, right? Whether it be block, we've seen more file in use recently, on-premises storage, local storage, as well as other data sources. So right, pick your source of storage, sinks for object, data services you might have in use, author your own blueprints. So there's a lot of flexibility in there in the system today. And then finally, we'll talk a little bit about just the integration before we start jumping into demos. When we go look at how we make it easy for both the developer and operator, we have native Kubernetes APIs. So these are things that Kubernetes RBAC applies to us as an example. You can set up roles. Our API is simply visible as an extension to the Kubernetes API, so easy to use. You can use tools like kubectl if you want to. But it's also about ecosystem. You can use Prometheus and Grafana to generate dashboards for us. You don't ever need to look at our dashboard. Use the logging system you're comfortable with, debugging, etc. So there's a lot of stuff in there. But also when we go look at some of the southbound APIs, we auto discover apps and all components in there. We will orchestrate with Kubernetes, so the operator developer doesn't need to worry about how that will happen. We take off a lot of their pain and allow them to focus on the data management. Full app capture, and as I mentioned, with via kanister, a lot of custom workflows also possible today. Okay. So we're going to next start to switch over into demos, and we'll hope that the demo gods are going to be nice to me. So we'll show K10 with Rancher on it, and we'll walk through 3 workflows here: the backup workflow, the restore workflow, as well as a cross-cluster migrate workflow. And we'll, periodically go back to slides for a little bit to show you what's actually happening underneath the hood there. All right. So let me switch over to my screens. All right. So I'm just making sure people can see my screen. Yep, we can. When I go look at the system out here, I have a couple of clusters set up. So this is RKE running on Azure right now. We're going to first start with for the first demo cluster, and then we're going to go over to the second in there. And when I go look at my clusters, I've installed a few apps through the Rancher catalog. And I set this app up a few hours ago, and we're going to go use that to mutate that, backup that, recover that, things of that sort. All right. So I'm going to switch over to the Kasten dashboard here. And this is the first demo cluster. So it'll be visible in the URL. This is RK demo. And what we see here is, I had a few apps running in there, and we do full app discovery in this particular environment. So for this particular application, we flagged it as not protected, and we've done full app discovery there. So we discover all the labels, volumes it might have used, all the configuration that it has, and we'll capture all of this in a second right now. Okay. Now before I even create a policy, let's actually go and add some data to this particular app. Okay. So I'm going to switch into my terminal here. So this is cluster 1. I have a bunch of nodes that I've deployed in there. And when I look at the namespaces, we're going to go work on the MySQL app that's in this particular namespace. So what I'm going to do is first extract the password for this so we can go log into it in a second. And let's go do this. Let's log into MySQL now. And don't do this in a production setting because I am actually using the command line to put the password in. All right, I got something wrong there. Wrong namespace. There we go, we're in. So let's look at the system here. So default system out here, what MySQL comes with, the internal systems, and we'll go create a database here. Let's say RK10 demo 1. And because we'll model a data outage later, let's go create 2 databases here. So that's done. We go look at show databases, and we have a couple of databases in there. So let's go back to the dashboard, and we'll go create a policy to protect this application. And in this case, we give the policy a name. Let's call it RK master. We specify the action that we want to do. We look at import and export later. In this case, we just want to back this thing up. We'll specify how often we want to do this. In this case, we're going to do this on an hourly basis, and we'll do a first invocation as soon as the policy gets defined. We could have gone down a lot lower if we had chosen to do so. And then this is what I was talking about earlier, where we have retention. how many snapshots or backups do we want? In this case, I'm saying I want 24 hourly, but this rolls off into just 7 dailies, 4 weeklies, monthlies, and yearlies. So there's a long chain in there, and you want to be able to pick holes versus just saying the last 50 hourlies as an example. Right? We won't export just yet. We'll do that later, but this could be a part of policies. In this case, we're just going to pick the application by name. But if we had chosen to, we could have also used labels in our system to go have broader policies that cross namespaces. But in this case, let me just go back and we'll pick the app by name there. We're going to go capture all the resources in the application itself. If we had chosen to, if there's something very sensitive, we could have filtered stuff out, both using include filters and exclude filters based on the resources you see in there. But generally, our recommendation is try and capture everything, and you can always filter stuff out and restore if you needed to. Right? So that's the policy that we have here. We're going to go say create policy. Excuse me. And that's pretty much it. Now, what you saw here was the dashboard, but underneath the hood, this is all YAML and custom resource definitions, if you're familiar with those in Kubernetes. So if you ever wanted to edit YAML directly, this is what the policy would look like. And there's a lot of documentation around this too. You can edit it through the dashboard, or in multiple places in the dashboard, you have these breadcrumbs that show you how to get to the policy, how to create it manually if you wanted to do so. So via kubectl, how you can edit it, create it. So this is how you could also plug it into any other pipeline automation if you had wanted to. Okay? So that was the policy. When we go back here, we see actually just kicked off and finished by the time I was walking through that. And in this particular case, the policy that we just created it ran on this namespace. And when we click on it, we get a lot more information, timing information, the artifacts we generated, volume snapshots, as well as all the specs that showed up in the system there. And that's pretty much it from the backup perspective. All right. Now we'll go back to the system and let me drop one of these databases to model a data outage. Right? So accidental stuff, wasn't planning on doing it. And I seem to have dropped a database. Let's do show databases again. And I only see one database in here. All right, obviously this is not something I wanted to do. So what we're gonna go back to our dashboard is go to our system and we're gonna restore an application. Right? And this is the snapshot we just took here. We could have even cloned it in a different namespace if you wanted to do a non-destructive test of this thing. We could have only brought back the volumes, or even sub-selected some of the specs, but not all of the specs. So there are options to go do these things. But for the purpose of at least this first part of the demo, we will just go restore everything in place. So let's do that. Okay. Now, a lot of this restore is actually dependent on Azure infrastructure speed, so it'll take a minute or two. And you'll see in a second that a restore job, will show up here. And it's going to bring everything back. If we had deleted the entire namespace, even that would have been okay. We just create everything from scratch. We repave all the app infrastructure. But I'm going to go back to my slides for a second to show you what you're actually seeing in this environment. Right? So we assume as the customer, you've picked some virtual or physical infrastructure. All the demos you're seeing are running on Azure right now. There is RKE running on top of that within Azure VMs. And the way we deploy is within your cluster. So no SaaS service, we touch your data, we're cognizant of how sensitive your data could be. And therefore we do not ever, you can run us completely dark if you wanted to. We integrate against the container orchestration platform API to discover, protect, restore applications. We also intersect against the underlying Azure API when we need to. So if you want to go snapshot and backup disks, if I want to move disks across regions, across resource groups, if you're familiar with Azure, how we use object storage. So there's infrastructure integration that we also do. And then finally, via kanister, if you had wanted to extend an app, we would hook into things at the application level by itself too. So hopefully this gives you a little bit of color as to what the system that we're demoing looks like. So let's go back to this thing. The restore is still going on. As you notice, I got logged out of my MySQL system because the pod was destroyed. But let's go look at the MySQL namespace and see what the status of things are. So it looks like, my bad. There we go. So it looks like this this cluster, the MySQL system is back up as the dashboard reported. It took a little under 2 minutes for this. And let's go back into this. The password still stays the same. The container we were using has changed. So, oops. And we go back in here. Let's do a show databases again. And as we can see, the database that we had dropped is now back present, right? Without really us having to mess around manually with PVCs, disks, things of that nature. All right, so let's go back here and we're going to now show an example of a cross-cluster migrate. So I have this system running here, but also if you had noticed on my earlier system, my RKE dashboard, I have a second cluster set up that doesn't have too much running in it. So the dashboard on this has a few applications, but we're going to move this MySQL demo app into this cluster in a second. And how we do that is we are going to use, these clusters don't need to talk to each other. They're in different resource groups. There's no networking needed, but we use Azure Blob Store in this particular example, some objects in between to move data around. So what I will do here is I'll go back into this. And what I'm going to say is, let's go export an application. Right? And this is, again, can be policy driven, automated, things of that nature. But I'm going to walking through this manually to get a little bit more color for what's happening there. I pre-configured an object storage location. In this case, there is a bucket in Azure in the region that the clusters are in. We're going, you get a list of all these things you will be exporting. If you say, I don't want to export that, it's a chance to back off. And we say export, right? And there's a piece of text that we use to handshake between the two clusters. You'll see that in a second on the other side. But at this point in time, we're exporting metadata around and potentially some data too, to go store that into the object store so that the second cluster can pick that up. Right? Let me go back here. Export completed very quickly, took less than 5 seconds in this environment. And we'll go to the second cluster here that you see, and we'll create what we call an import policy. So I'm not running this in dark mode to make it easier for us to look at which one's the second cluster, which one's the first. But let's give this a name. Instead of backing up, we're going to do an import. I could have picked restore after import here too, that automatically brings the entire app stack back up. But we'll do this manually to again get a little bit more insight into what's happening. We ask how often we want to check the object storage location for more data. And then I'm going to paste the text that I had copied from the source cluster. And there's also, right, it points to the same profile that the source cluster had put stuff into. Only in this case, we're using this to import data in. All right, so we have the policy was created. And it will do a couple of things in a second. So give a second for the job to kick off. And what it will do is it will go and create what we call an import job. In a sec, should show up. There we go. And it'll take a couple of seconds. Again, very quick on the import side, and it just brought stuff in. If there was no new data to bring in, it would not do any extra work. And let's go and bring that app back up. So the MySQL demo in this cluster obviously does not exist right now. Let's go to the command line to make sure about that. There's an older MySQL in there, but the MySQL demo app isn't running in there. What we will do is, there's a notion of an invisible app, something that isn't currently running, but that we have information for, and we're going to go restore that. Right. So this is the restore point that was created on the other side. We'll restore in the same place, and we'll bring again everything back in that we needed to. So restore. And similar to the restore process in the primary cluster, that is kicking off right now. All right. So it takes a second. Let me also again walk you through what happened here and in the more general case. So when we migrate across clusters, and this is a more involved case specific example, you're going to a public cloud and on-prem, we obviously do an app snapshot that is all your Kubernetes resources, and we punch holes for things that are not always portable, sometimes even across clusters in the same region. Think node ports, if you're familiar with those, or other things when you go across distributions or across clouds. If you had volume snapshots, we also convert them into an infrastructure independent format. We deduplicate that, and we put that into an object store that the destination cluster can then go restore. All right. And we optimize this. So for example, if you detect that we're doing in cross region but same cloud transfer, we don't always need to do this infrastructure portability for volumes. So depending on where you're going, how you define your policy, underneath the hood, different data transfer mechanisms kick in for best cost and performance efficiency in there, right? So in this case, the restore is ongoing. Let's go back, look at what's happening here. So we saw that the new namespace was created that didn't exist earlier. And the pod is starting up. So it'll take a few seconds again for this to happen. But what it is doing right now is it created the namespace. From the snapshots that it imported from the source cluster, it created new volumes, created new PVs for that, PVCs for that in the application namespace, and then the app stack back up on top of that. Right. So now we're waiting on Azure infrastructure to do some of this provisioning, but that should happen in roughly a minute or so right now. So we'll give that some time. And then as soon as that happens, we'll again log into the system, see if the data is present and what we can do there. So let's go back here. And as jobs are also ongoing, there's a lot more information available for that. We see the volume actually already got created. Now we're trying to bring the app stack up on top. And again, if you wanted to look at this via the command line, just in other ways, you can also, right? You have the kubectl commands in there on how to get at some of the API objects here. All right, so the pod's now up and running. So let's do the same thing where let's get the root password for this thing. And let me log into this. All right, we are in there right now, and let's look at the databases. And as you see, so it's not the default MySQL setup. The databases we created on the source side, the ones we captured during a backup, are now present on the restore side. All right. So I'm going to stop some of the demos here, but let's switch over to Q&A, and I will hopefully illustrate some of this if by going back to the live system, if there are questions around some of that. Okay. All right. So looking at things, one of the first questions was, for customers who are including database services in Kubernetes, what was the driver of moving database in Kubernetes versus using the usual architecture? Great question, and we actually we see this over and over again. One of the biggest things, and it depends on the kind of organization you're coming from, but one of the biggest things we see is people not wanting two different control planes to manage the system. So if you have Kubernetes, you manage the data within that. You are right, you have the same tools and there's uniformity. But as your organization grows, it opens up a lot more possibilities. You start giving developers more control over the databases they want to run. Test dev becomes significantly easier. Sometimes, not always, but sometimes you also move away from VMs to containers, and there's a licensing cost decrease if you're changing systems there. But overall, it is centered around ease of use and the additional things it opens up. Because if we step back a second, what are some of the reasons that people look at Kubernetes? It is not always cost or infrastructure savings. It is agility. It is the ability to move faster. It is the ability to compete better with other companies out there. And that's why people want to bring databases within Kubernetes. Yeah. Um, so people ask, there's another question around, are there any limitations with Kasten, for example, if an application has hundreds of gigabytes of data? In short, the answer is no. We test with large amounts of data, including multi-terabyte data sets. Today for Kasten, we're not a fit for big data style applications where you have petabytes of data. That's not a target market yet, but hundreds of gigabytes of data is very simple. And we actually have a lot of specialization for the kind of data sets you have. If you're running a multi-terabyte MongoDB database, you want to do things differently than if you have a few gigs of data in there. So there, when you get into the details, there are a lot of things you can do to optimize for performance and cost in your environment. And if I don't also answer these questions well, if you have follow-up questions, please obviously feel free to ask additional ones. So I got a question that said, if I understand it correctly, Kasten also backs up the data in a PV of a pod. But where does Kasten save the backups for that data? Okay, great question. So this is a customer choice kind of deal. We have, where we store backups is generally in a system that is different and isolated from your primary storage. Usually we do that in some object storage system. And let me go back to my live system to show you how some of that works. When I create what we call mobility profiles here for exporting these backups, you can pick multiple object store options, Google, Azure, AWS, on-prem options. We have customers that are doing DR from Google Cloud into on-prem as an example. So you can not only pick your choice of object storage, but also the location as to where it might go into. All right, so moving on to the next question. Can we do the same for distributed databases such as Neo4j? I believe the answer is yes. It's been a little while since I've looked into Neo4j, and some of the things it does with its graph database is interesting, but I believe we can handle it, both from the crash consistency point of view, but also because we have the hooks to intersect with Neo4j's APIs for things, so we can suck data out at the API layer again. So that is definitely an option. And again, something I would like to stress, even if Kasten or K10 out of the box doesn't say we have support for X, it's actually fairly easy to focus on just the data management components of your database. That is, how do I extract data from my database and plug that into a system without having to worry about the Kubernetes machinery that might be involved. So you don't need to worry about where the code runs, who runs it, what happens when the failures, monitoring of that. We take care of a lot of that for you if you have something custom that's not an off-the-shelf NoSQL or relational database system. All right, and so we have right now what might be also the last question that wasn't repeated. But if there are more questions, please feel free to feed them in, and happy to take those too. But we had a question that asked, does Kasten provide functionalities to ensure data consistency when performing backups of data in a PV of a pod? The answer is yes, and it's more than that. So we have a full spectrum from crash consistent, app consistent, data service consistent, as well as distributed services consistent. So it depends on what your needs are and the different trade-offs wherever you might be on the spectrum. But you pick this on a per app basis. And sometimes we have simple hooks for things like freeze, quiesce, flush data in a database, take a volume snapshot, unfreeze that is quick, all the way to using tools like XtraDB backup with MySQL or Wally with log shipping for Postgres to get point-in-time recovery and point-in-time consistency. So all of those are options today. And we had one more question come in. Does the snapshot method used to restore applications and database are transactionally consistent? I mean, databases with data across several PVs. The answer to this one is going to be slightly more nuanced, where we talk about two things. So I'm just trying to figure out the simplest way to explain this. When we restore, if a database is spread across a number of PVs, generally the short answer is yes, right? That's a too long didn't read answer. That is, it will be transactionally consistent, sometimes because the databases themselves will do a fix up when you're recovering from that. If you have needs to quiesce across data services, say I have Elastic running and I have Postgres running in the same context of the same app, we have the hooks for you to be able to quiesce that, but that is not something we can control because we don't know how your app behaves, what your data model would look like. So there's some extensibility required there, but generally speaking, they should be transactionally consistent. It's only the point in time that might vary. There are people that talk about in terms of this is somewhat of a more product offering question, right? We have a free to use start edition versus an enterprise edition. What editions exist in the enterprise versus starter? There is no difference between those two versions apart from size restrictions that we're also expanding either today or next week. But all features found in enterprise are found in starter. Can we restore single objects like tables from backups? That is a part of our roadmap. We don't have it today. What people have done in the wild is what they do is, let's go back to my dashboard here. And let's say I was bringing my SQL back. I'm going to say restore app. I pick that, and they'll generally clone it in some other namespace in the same cluster, and then be able to extract individual objects, introspect on what they need, and bring that back. So that's the way you can service that workflow when you need to bring individual objects back today. But more first-class support for that is a part of our roadmap right now. Okay. All right, so I seem to have run through most questions at this point in time. I can still hang on for a couple of minutes if there's anything additional, but otherwise, I would really like to thank everyone for the time here. I know how precious your time is. If you have questions, feel free to reach out to either one of us. You can find us at kasten.io, find me on Twitter, drop me a link. The slides and the recordings will all be available online soon. But I will turn things back over now to, I believe, Ryan, who can wrap things up, Kyle, sorry, who can wrap things up.
Yeah, thanks for that. That was a really great presentation. If no one else has any questions at this time, like we said, this will be up available online for you to review, as well as the slide deck. So thanks everyone for coming, and look forward to future masterclasses in the near term.
Thanks everyone.
Thanks.